What do you usually do in your summer break? Well, going on a trip, hiking, partying maybe, or even going to other states, uh, trips, cycling, this and that. The possibilities are enormous, right? But do you want to know how I spent my summer holidays? I read 42 research papers. That's right, 42 research papers from IEEE. So that's how I spent my amazing holiday. And I gotta say, I'm not complaining. I am not complaining at all because all these 42 research papers, right? I read it end to end, and all those topics were about security in AI agents. And I gotta say, it excites me so much because for me personally, nothing excites me as much as when I see a particular domain that has a lot of potential for people like us, researchers, innovators, to come forward and build solutions to make the world a better place for the problems that already exist. I love doing that. That's my trip, that's my partying, that's my hiking. And yeah, it's this is a very unique summer experience, and this was part of my directed study course, which I have taken under Professor Ben Othman, really amazing professor. And uh, and very recently, I've got a chance to speak about what I've learned in to an audience in one of the Dr. Ben Othman's classes. So my audience were his classes students, and I went there. I just explained what I found, how I did it, and what are the gaps and everything else. So this is what this particular video is going to be about. So I hope you enjoy my lecture. I hope I don't bore you guys. And yeah, before watching that, make sure you do the necessities, like the video, subscribe to my YouTube channel, and comment down below what you think in general about this particular topic, or if you have any questions, do ask that. And let's also get connected on LinkedIn. I'll be putting the LinkedIn link to my profile in the description below. And enjoy the video. Yeah, so good morning, everyone. My name is Samuel Jerome. I'm a master's student in AI, as well as I'm also the AI agent developer at UNT. I work as part-time over there. So my topic for today is security in AI agents. A literature survey that I did for the past 2 months. That's how I spent my summer holidays. So I'm here going to talk about this particular topic. And so before that, just an icebreaker question: how many of you guys use ChatGPT or Claude or Grok or any other LLMs as a personal therapist? Because I do. Does anybody else do that? No need to feel ashamed, because that's totally normal these days. Cool. So, but have you guys ever thought that all the personal data that you input to that a particular LLM, that there is a chance that that data could be compromised, that someone can hack into it and get that data? So that is the question that we're going to talk about today. And yeah, let's jump right in. So before the topic, I'm going to tell you what's the method that I've done so far to get the findings that I did. Well, I followed an approach called the systematic mapping research. This methodology is basically that
I just went to the IEEE Explore website and I searched for keywords for my research. The keywords are, hey, search about agentic AI security, LLM agent, prompt injection, adversarial attacks, and a few others too. So when I did that, of course, I don't want the outdated ones. I want the latest ones. So I searched for papers in the year 2021 to 2026 and to see the current state of things. And when I did that, I was able to find 52 papers in total. But after filtering, after finding out papers which closely align to the topic, I found 42 papers actually showed what I really want. And then after gathering that, after putting all together, I was able to find three main topics that I could find common in all these 42 papers. And they are security assessment of agentic AI systems, attacks on AI via poisoning, attacks on AI models via evasion. So what are they? So for the first topic is basically like, hey, can we actually trust this thing? Can we actually trust LLM models? Are these autonomous agents are really safe, robust? Are they behaviorally consistent when operating without anybody's looking at it? And then the poisoning attacks comes in. What is poisoning? So this attack happens during training. The model isn't even ready yet. So while training, somebody inputs and a bad data into it to corrupt it, and that's what happens here. The evasion is the opposite of poisoning because this happens when the model is already trained, ready, deployed. So, and then in the adversary, the attacker crafts a specific input to make the model to fail. And then we have and then I have read through each and every 42 papers, and then I was searching for these particular 6 points in all of those on all of those 42 papers that I've read on. What are the problems being addressed? What is the AI ML technique used? Threat model and adversarial assumptions, proposed defense, and the experimental setup. What are some limitations and the future directions? Now here is a video of the federated learning example. So I'm going to pause it right here, because in this example, basically what federated learning means, well, let's say you have a collection of hospitals, right? And you want to create a cancer detection model. Now, one hospital cannot share its data to another hospital because of laws. So each model, each hospital trains their own model for cancer detection purposes with the data that they have. And once that is trained, they send that particular data to the central server, which has all the data from all the hospitals over there. But no specific or no hospital-oriented information will be there, but just the behavior thing. So this is how the federating learning example works on. And this concept was discussed in a lot of papers that I've read. So that is one thing. And the other thing is the dominant. So what are the other dominant AI ML techniques used here? Well, we have the deep neural networks, we have CNN and DNN, and also obviously LLM based agents. Poisoning attacks. Okay, as I said before, poisoning attacks happens when during training. The adversary influences the model before it is ever deployed. So there are two types of poisoning attacks that I've noticed in my research. Is obviously the data poisoning. The attacker maliciously samples into the training set, causing the model to give incorrect answers. And we have backdoor attacks where this attacks came up so much in my corpus, where it overall degrades the overall performance in it, and it gives significant attack results. Now let's see how does a backdoor attack actually happens. So here you have this model. I want to pause it right here. So you have this model, which analyzes, let's say, images, right? And in this particular situation, you have a particular image where you just the attacker just have to change one pixel, let's say a small yellow dot over here, and when he changes that particular thing, well, the AI models won't be able to detect that, and that is a trigger itself, and that causes the model to change its behavior that the attacker wants it to do. So this is a particular example for the backdoor attacks. And the next one is the poisoning in federated settings. Well, we all know right now what is federating learning means. In federated settings, well, I went through all these papers where the first one is FedRec attack, uh, HID attack, and FGLBA, backdoor against split neural based vertical federated learning. So all these is basically like, what if one of the client in the federated learning setting is compromised, and what if they are giving the false data to the central server? In that way, malicious intent can be done that the attacker really wants. So this is basically that. Now other one is, now this one is my favorite because it talks about cats and dogs. Well, this is the clean label attacks. We all know of this simple project where we train the AI model, hey, this is a cat, hey, this is not a cat. And as a human, we can actually distinguish properly unless we failed at elementary school. But anyways, so in this particular label attacks, we do not flip the label. We do not say a cat is a dog, but instead we make changes in the pixel, in the input itself, very minute changes that the model will say will get compromised and classify in a wrong manner. So this particular paper, clean label attacks against SLU systems, is basically speech language understanding systems. So this is not only in images, but this also extends to audio itself. And the other paper, the deep learning based regularization as defense against clean label targeted data poisoning, is a defense mechanism to this particular attack. And then we have the evasion models. So opposite to poisoning, evasion models is where the model is already trained, the model is already validated and is operational, but the attacker then crafts a particular input that misclassified without making huge changes in the model itself. And this FGSM, which stands for fast gradient sign method, is the most frequent applied technique from all the research paper that I've gathered so far. And there are three particular papers that talk about this evasion attacks, is like adversarial attacks for speaker recognition system with this. And so these are the three papers that talks about here. And now we have seen all the possible attacks that happens behind the screens, behind our screens. But do you guys realize that there are also attacks that is outside our particular screens as well? Well, we have sensors, we have different types of cameras, and attackers infiltrate that as well. For example, this paper, physical realizable adversarial attacks on 3D point clouds. So LiDAR technology, right? We all know Waymo. Waymo uses LiDAR technology. So this paper talks about that it physically creates an object in its LiDAR system that attacks that particular model to make wrong decisions. So this attack talks about that. And the other one is the face recognition. So it addresses about biometric systems that are currently deployed in our for device authentication, phone unlock, or even security at the airport. It has been used to infiltrate that. And so far it is we have seen about images. Now it's about text. Now text is a little bit complicated because in images, right, we can change an image pixel by a value of, let's say, 0.001%. That is like very minute, and our humans cannot like easily detect that. Even obviously the models cannot easily detect that. But in the text, the attackers has to be like, they have to be very smart with it, because they have to know, okay, when crafting a particular system prompt, they have to know, okay, a simple word change, a substitution change, or even the entire structure of it, and only within that they can actually infiltrate, attack this particular system. And the affected systems include like content moderation, spam filtering, sentiment analysis, and even toxicity detection as well. So here, let's talk about AI agents. Let's go back to the basics now. Does anybody know what an AI agent is? Very simple question. Can someone say what an AI agent is? Open to audience. In simple words, not very complicated question, right? Yeah, so the term that you said, searches, right? So that is a task, and the prompt, you give it a command, you instruct it. So it basically, that's what an AI agent is. We instruct an agent to do a particular task, and that's what an agent is. So what happens when an attacker attacks it? Well, it does not do the type of task that you want it to do. So that's the thing is about prompt injection. Now, I really like this particular paper. This is my favorite paper of all the 42 papers, because it talks about LLM agent against prompt injection with this particular method. So I have told you guys that I work in UNT as an AI agent developer, right? I make all these agents for UNT's workflow, and some of them it's about that deals with psychological data. Okay, I work with clinic as well. I work with their data, and those data are like very, very valuable. If they get compromised, then HIPAA compliance, that would become a whole legal issue by itself. So I have to be careful with that. So I have to craft a prompt in that way where it doesn't, when a prompt injection, when somebody like intelligently crafts a prompt and tries to infiltrate my agent, my prompt has to be like, stay vigilant, stay rigid. So this paper basically is that it gives an approach of dynamic system prompt changes. It dynamically changes the system prompt instructions. In that way, the attacker does not have a particular clue. Okay, whether, okay, this might be actually the system prompt. Okay, I can craft my prompt injection in this way and attack it. No, it dynamically changes. So that's very interesting about that. The other papers are obviously the enhancing risk awareness in LLM agents, and yeah, and a few more. This particular paper talks about what are the basic threats, defenses, and open challenges that are out there. So now, the paper not only talks about the different types of attacks that has been done to the AI agents. There are also papers that talks about where the agent itself is the attacker. There are two papers that I found where the autonomous cyber security with security augmented generative AI is basically an AI system that does cyber security attacks. And then there's another AI where it independently conducts defensive operations. So we live in an era where AI is the attacker as well as the AI is the defense person, and we are just the audience of. Okay, now let's talk about the defense. Enough of the doom. Now there are a few types of. I've seen these four common different types in the corpus that I've found. The first one is adversarial training. So where we train a particular AI model with all the attacks that is already there, so that it overcomes that. And the second one is protection layer architectures, where we wrap an AI model with different types of protection layers so that it stays rigid against attacks. And then we have backdoor detection and unlearning, where you basically make an AI model unlearn a particular trigger that is given to it, so that the data that it has stays clean and it doesn't get triggered by the trigger. And then we have the LLM agent based defenses. Okay. So the next one is the limitations across the corpus. So four limitations, they constantly appear in the corpus, and the first one is limited generalization. So the proposed defenses are validated on a particular architecture, but with no assurance of transfer to another different types of architecture. And then the other one is the high computational cost. Well, these defenses are done in a lab setting, in a research-based manner, where the cost of maintaining that is really high, but in real-life scenarios, it can be very expensive to do that. And then the absence of adaptive adversary evaluation. Now, okay, we already know the types of attacks. We already train the AI models with the different types of attacks. We make it rigid with the data that we have, but the attacker is like very adaptive. How is it going to be dynamic? How does it dynamically change uh, to the attacker's adaptive methods? So that is there. And then the last one is limited real world scalability. So let's see the scope of this particular field. Where does this field actually stand? So I built this in Claude Code yesterday night. Yeah. So from my corpus, there are 4 tiers of maturity, and there are classical adversarial ML, where the evasion and poisoning and computer vision, the defenses and the attacks are like very well developed. They're not solved yet, but they're understood by it. So this particular topic is very mature. Second one is the federated learning security, and then the LLM agent security, and then we have the physical world robustness. Then who has the standard benchmark? Well, computer vision has all the points. The second one is the audio. Well, the third one is the network intrusion. Well, they're not as prevalent as computer vision or audio, but they're somewhat there. Then below that we have federated learning, but LLM agents are not there at all. So over here there are 2 papers. Okay, there's paper A and paper B. Paper A is says that this particular defense accuracy that they have worked on is like 85% there, and the paper B is saying that this defense accuracy is like 91%. So let's compare them and check their evaluation. So there are different tests and different scorings, so these numbers like cannot be compared, because over here in paper A, their test set was like 200 self-written prompt scoring. They have done manual review, and over here in this test set is 1400 scrape injection scoring, keyword match. So they are totally different to each other. So here you can find that the scope of this particular field is like very high, and the gap is real. The next one. So what are some best practices? The best practices, the first one is the conduct threat modeling before the deployment, and then we have the evaluate against adaptive adversaries, then apply a robust aggregation and anomaly detection in federated learning, and then we have the defense layers for LLM agents and document limitations. So conclusion is that, the corpus 42 IEEE papers from 2021 to 2026 read in full. The analysis I went through that, structured extraction of all the 7 columns, the problem statement, AI ML techniques, the scope, the three subtopics of the scope: the AI agent security, poisoning attacks, and evasion attacks. So the principal finding is that attack methodologies, they currently advance faster than the defense ones, and the gap remains high. The gap remains between the demonstrated laboratory results and the real world deployment is very, very high. So that's what makes it very exciting for this particular research. It gave me a huge exposure as an AI agent developer to work on these particular stuff so that I can implement best practices in the models that I create in future on. So this is my research work. I hope you like it. Thank you so much. Thank you.
So welcome to the promotional portion of this video. Well, I do not have any sponsors or any products to sell other than myself. I am the product. Oh, well, because I'm a master student in AI at UNT. Furthermore, I'm the AI agent developer at UNT. I have built so many AI agents for UNT, whether that deals with data entering or automatically data entering in various documents and various document creation and so many other stuff. And I've worked on so many healthcare AI products, like for example, in my latest uh, project was from my internship, which deals with accurate phoneme segmentations and so many other projects that I have built. So I bring this various skill set with me, and I also have an experience in having my own AI startup back in India, where I was one of the co-founders for it, and we generated revenue successfully and ran the startup successfully for one whole year. So I have these kind of very unique experiences with me and the amazing set of skill sets that I have. And if you think I would be that I could help you guys in your particular venture, startup, or your company, then feel free to reach out, and I will be very much eager to help you guys from this December onwards. I am looking for roles like AI engineer, data scientist, AI agent developer, and even developer positions too. So I'll be leaving my LinkedIn profile link in the description below. So if you want to get connected with me uh, and to talk about how I can help in your company with my experiences and skill set that I have, then do feel free to reach me out in LinkedIn and let's talk.
Subscribe to the Late Night AI Show.
AI has already learned.